In previous sessions, we've looked at how we can represent robots and other devices in a manufacturing environment. But in most factories, people also perform tasks both involved in handling materials and in operating equipment. So we'll have a look now at how we can represent humans and human tasks within a digital manufacturing environment. To do this, we'll look at the Delmere workbench for ergonomics, the study of human activity. So I'm just going to load up the Delmere workbench for ergonomics, and we'll see within this there are a number of sub-workbenches. We'll start with the human builder. Delmere and other such tools provide default libraries of standard human beings that we can then tailor to suit our own particular situation and to give tasks to. So I'll start by inserting a standard mannequin, and I'll call this mannequin Neil. It'll be me, or a mannequin of me. It's a man, and it represents 50% of the population of men. Now, optionally, I can, if I wanted to, I could make myself a woman, but optionally I can also specify a particular population that will size the characteristics of this human being. And I'll take a French person because they're European and I'm British, so I'm European. And I can set a definition or reference point, so this is between the feet, so that the mannequin will be positioned on the floor with a datum between the feet. So I can have a look at my mannequin. It doesn't quite look like a human being, but trust me, the basic movements are pretty representative. It has the usual components of a skeleton, right arm, left arm, and so on. And if we look within the left arm, the structure of the left arm has various, bones essentially, shoulder, arm, forearm, and hand. And within the hand, although it's not shown directly under the hand, we have the fingers, including the thumb and joints within the thumb. So we have the 3 joints that most of the digits on a human being have. The human thumb, in this case, is shown with 3 joints, although it appears to only have 2, just to give it the complete articulation that we need. So there's our human being, and you'll see that there are a number of tools that we can now use in posturing the mannequin. We can drive them forward kinematically, inverse, and we can give them standard poses like sitting down. So I'm going to use forward kinematics. I can then select a part of the skeleton and I can move it within constraints that hopefully represent the constraints of the human body. So there's the right forearm rotating, the right shoulder rotating, and I can rotate each bit. So this is driving it in the forward kinematic direction. But perhaps more usefully, I can use inverse kinematics to select part of the body, snap the compass onto it, and then I can move that, and the ergonomics, the kinematics engine solves the problem and moves the joints appropriately. The system will only allow me to move the object into valid positions, and it will give me warnings if I try to exceed these, so I can tilt the head, but only so far. If I try to tilt things further than is possible, then it just won't let me. Later on we'll see how we can use this feature to look at stress within the human body and within human tasks. So this is a standard human being, but let's play around a little bit, and I'll make this look a little bit more like me. So I'll give him blue eyes, slightly bluer eyes than he had before. And there we go, there's his blue eyes, looks a bit spooky. And the hair, not white, although I am going grey. So I can't be bothered to look for a better grey. I'll use the default grey in that window. So they're grey hair. Okay, and there's our human being, and we've seen how we can manipulate it. The next thing really is to put it into a work environment and give it tasks to perform, see whether it can perform those tasks and what kind of stress that mannequin would be under in performing those tasks.